So in this class, I will solve a problem on locating the centroid of a composite section. It is a VTU question paper problem, January 2019. So this is the problem given. So here this composite section consists of a rectangle of dimension 120 by 80 mm. So all the dimensions are in millimeter. All dimensions are in millimeters. So it consists of a rectangle of dimension 120 by 80 mm. Then a triangle of base 80 and height 60, and another triangle of base this becomes 40 now, base 40 and height 60, and a cutout portion of a quarter circle with radius 80 mm. So this is also 80 mm. With radius 80 mm is cut out from this entire section. That means it consists of totally 4 simple sections, one rectangle, 2 triangles, and 1 quarter circle. Out of that quarter circle is a cutout portion or a hole. Therefore, area of quarter circle we have to take it as negative. That I have explained in the earlier lecture. Now I will take the x-axis as the bottommost edge. So this I am going to take as the x-axis, and leftmost edge I am going to take as the y-axis, so that the coordinates x bar and y bar of the centroid will be positive. So x bar will be to the right side of y-axis, y bar is below x-axis. Therefore, both will be positive. So if they don't give any axis of reference, you can choose on your own the axis of reference. Here, in that case, if the figure is not symmetrical, then bottommost edge you can take it as x-axis, and leftmost edge you can take it as y-axis, so that all the values of x bar and y bar you are going to get as positive. Now here, I will solve the problem once again by writing the tabular column. So serial number, figure, area, AI. So this area will be in millimeter square because dimensions are in millimeters. Then you have the xi value. Xi is the distance of the centroids of the simple sections from y-axis. The xi value will be in millimeter. Then we have yi value. So that is also in millimeters. Distance of the centroids of simple sections from x-axis is yi. Then you have the product ai xi. It will be in millimeter cube. Then ai yi. That is also in millimeter cube. So here ai is nothing but the areas of the simple sections. As already told, we have 5 simple sections here. So the first one being the, I will take this first one as a rectangle, second one this triangle, third one this small triangle, fourth one as the quarter circle. So serial number 1 is the rectangle, figure rectangle. The area of this rectangle is 120 by 80. So 120 into 80. Then xi is the distance of the centroid of this rectangle from y-axis. So here this rectangle centroid will be here. So definitely this will be your G1. So 1 stands for the rectangle. Centroid of this rectangle will be here. Distance of the G1 from y-axis is x1. That is your first value of xi. So which is half of 120, it becomes 60. Then distance of G1 from x-axis, it is nothing but half of this 80, that is 40. Please note that all the values of x and yi they are positive because I have taken leftmost edge as y-axis, bottommost edge as x-axis, so that all the x values and y values they are positive. They lie in the first quadrant. So then second one. So we will take the product later. First I will fill all the first 3 values. Then we will take the product and we will add. Second one is the small rectangle. Right angle triangle, that's a small triangle. Right angle triangle. So triangle So this is the big triangle. Big triangle is this. Area is A2 there. So its area is half into base into height, half into 80 into 60. Half into 80 into 60. Now I will locate the centroid of this triangle. So it will be here. G2 will be here. So you know that G2 will be at a distance of, in the case of a triangle, already we have derived the expression. So if this is the triangle, rectangle triangle, G is here, and if this is B, then from the vertex it will be at a distance of 2b by 3. Okay? And from this side it is b by 3. So therefore, x value for this G2 is, since we are measuring from the vertex, y-axis is at the vertex, 2 by 3 of 80. 2 by 3 of 80. Then yi value is the distance of this G2 from x-axis, which is nothing but from here to here is 80. 80 plus, this is 1/3 of this 60. So suppose if this is h, so we have proved that centroid will be at a distance of h by 3 from the base, that is 1/3 of 60. So 1/3 of 60 plus this 80. 80 we have to add because we are measuring from x-axis. So it will be 80 plus 1/3 of 60. That is the second value. Now the third value is the triangle once again. It is a smaller triangle. Small triangle. For the small triangle, this triangle, once again is rectangle triangle. Area is half into base into height, half into 40 into this 60. So half into 40 into 60. And if I locate the centroid of this, it will be here, G3. So x3 will be distance of this G3 from y-axis, which is nothing but 80 plus 1/3 of 40. 80 plus 1/3 of 40. So you should be very careful in writing these distances. 80 plus 1/3 of 40. Then this yi distance is from here. It is 80 plus 1/3 of 60. 80 plus 1/3 of 60. So that is the value of yi. Then fourth one is the quarter circle. Please note that the quarter circle is a cutout portion or a hole. It is a hole removed from that total lamina. Therefore, this area is negative. So please note that area is negative for a cutout portion. So area of the semicircle is pi r square by 4. So pi into r is 80. So 80 square by 4. Please note that this is negative value because it is a cutout portion. That is very, very important. Then the value I will locate the centroid of this quarter circle. You know that if you draw a 45 degrees line, centroid lies on that line. So that it lies in such a way that this D4, so this distance from the diameter, this is the diameter axis. From the diameter axis it is 4r by 3 pi. But I need the distance from y-axis. Therefore, what I have to do is the total distance 120 minus 4r by 3 pi. So x distance is 120 minus 4r by 3 pi. R is 80 here divided by 3 pi. That is the x distance. Y distance from x-axis is 4r by 3 pi. So it is 4 into 80 by 3 pi. So these are the x and y distances. Please note that here this is a cutout portion. Therefore, the area is negative. Only for this it is negative. All the other areas are positive. Now, once you get these three values, areas, x values and y values, now you have to find three sums here. The first sum is summation ai. Then next is this ai xi you have to find out, and ai yi you have to find out. Then we have to add them. So sigma ai xi, sigma ai yi. So these things we need. So this will be in millimeter cube. This will be in millimeter cube. Whereas area is in millimeter square. So once you complete this table, then you can, using the formula, you can find out x bar and y bar. Now let me write the values now. So here this area 1 into 8 is 96, 9600. Here it is 80 into 30, that is 2400. Okay, 2400. Here it is 2400 divided by 2 means 1200. And here this value is minus. So pi into 80 square. 80 square divided by 4. So 5026.5. So this value is 5026.5 millimeter square. Now, so we have to get the sum of these. These three are positive, this is negative. So 9600 plus 2400 plus 1200 minus 5026.5. So it comes out to be 8170.5. 8173.5. That is the sigma AI value. Only the last value is negative. Now multiply this A with X. You are going to get AI XI. The first value is 9600 into 60, which comes out to be 576,000. Second value is here. Once again 2 by 3 into 80. So 160 divided by 3. It comes out to be 53.33. And this one is 80 plus 13.33, 93.33. And this value is 4 into 80 divided by 3 divided by 5 minus 1. So 86.05. 86.05. Now multiply these A values with X values to get AIXI. So 2400 into 53.33. It comes out to be 127992. 127992. Then 1200 into 93.33. 111996. Next, this value negative 5026.5 into 86.05. So negative value minus 432. Minus 432,530.3. So this is the AIXI value. So we have to add this. Only the last value is negative. So if you add 576,000 plus 127992 plus 111996 minus 4325.0.3. So it comes out to be 737.7. So this is the value of AIXI in millimeter cube. Now coming to the last column, you have to multiply this area by YI value. So 9600 multiplied by 40. So it is 384,000. Then here this is 80 plus 20, 100. This is 80 plus this is also 100. Then this is 4 into 80 divided by 3 divided by 5. 33.95. 33.95. Yes. Now we will take product of A and Y. First one is over. Second one is 2400 into 100. It comes out to be 24 followed by 4 zeros. Then the third value is 1200 into 100, that is also 100. So 1 2 followed by 4 zeros. Next you have negative value here, because A is negative, AIYA is also negative. 5026.5 multiplied by 33.95. So negative 649.7. Yes. Now if you add all this, last one is negative, you will get sigma AIYI. So 384, 3 zeros plus 240,000 plus 120000 minus 170,649.7. So it comes out to be 573,350.3. So this is the value of sigma AIYI. Now by using the formula, x bar is equal to summation AIXI divided by summation AI. So you will get 737.7 divided by sigma AI is 8173.5. So the value now becomes 737.7 divided by 8173.5, which is 94.54 millimeter. So this is the x bar value. Next y bar, similarly summation AIYI divided by sigma AI. AIYI is 573,350.3 divided by 8173.5. So 573,350.3 divided by 8173.5, which is 70.15 mm. That means the coordinates of the centroid is 94.54, 70.15 millimeters. The centroid lies at a distance of 94.54 mm from y-axis and 70.15 from y-axis. So this is the 70.14. Okay. X bar I will check once again. Just check once again x bar value. 9600 into 60. Yes. 9600 into 60. 576000. Okay. Then 2400 into 53.33. 2400 into 53.33, which is 127992. Then 1200 into 80 plus this time, 80 plus 1/3 of 40, which is 1/3 of 60, so 100. Okay. So this time 13.33. Okay, 93.33. XI value for the third triangle. Yeah, correct. Okay, so it is 1200 multiplied by 93.33. Okay, 111996. Okay, then pi r square by 4. So pi into 80 square divided by 4, 5026.5, which is a negative value, and this distance of this centroid from y-axis is 120 minus 4.35, so which comes out to be 33.95. So 5026.5 into 86.05 is 432530.3 negative. Okay. Now this value, if you add 576000 plus 127992 plus 111996 minus 432530.3. This answer is what I did. So this answer you are getting 383457.7. 383457.7. Be very careful, that's right. Now this x bar value will change now. So I will take this sigma ai xi is different now. X bar value will change. So sigma ai xi is 383457.7. If you divide that by 8170.5, 47.5. Yes, so 47.5 mm is the value of x bar, 70.15 is the value of y bar. So once you get those two, now you can locate the centroid of the composite section. Once you get the values of x bar and y bar, now I will show how to locate the centroid of the composite section and shaded area. So the given shaded area is something like this. This is x-axis, this is y-axis. I have taken like this, and of course here you have the like this you have. Okay. Yes, this is the given shaded area. So once you get the value of x bar and y bar, you can locate that here. So x bar is 47.5. So this is 40 actually. 47.4 maybe somewhere here, and 70.15. This is 80. Total is 80. So therefore, you can have your G somewhere here. Here you can have. So this is x bar, and this is y bar. This is where that key lies. So please note that the centroid lies in the region where the area is more concentrated. Therefore, in this case, you are finally finding the centroid of the shaded area. Definitely, it will be somewhere here only. So after getting the values of x bar and y bar, you can just show that in the diagram. So this is how we have to solve the problem of location of centroid of a composite section. First, we have to split the composite section into simple sections whose areas and distances x and y can be located with respect to the reference axis. Fix the reference axis. So if the figure is not symmetrical about any of the axes, then choose the bottommost axis as the x-axis, leftmost axis as the y-axis. If it is symmetrical about any of the axes, then you need not find both x bar and y bar. Only one thing is enough, because the centroid lies on the axis of symmetry. The concept you know. Then write down the simple sections, their areas, distances of their centroids from the reference x and y axis. Then take the products, take their sum. Then use the respective formula to find x bar and y bar.